So we are now on the flip side of the contest, and it is about almost 2 a.m. local time. I'm going to try and film as much as I can. I'll probably only get out about 15, the first 15 of the AMC 10, hopefully, fingers crossed, before my energy's just gone. I will also try to get out probably the first 10 or so of the AMC 12. It'll get you started. I did solve up until around 15 on the AMC 12, and I solved till around 19 on the AMC 10 so far. But I'm not going to get all of that filmed in the small amount of time that I have. Try to get this released at 5 a.m. But here we go. Let's get started. As far as my thoughts on what I think cutoffs and all that will be in difficulty, I will make a separate video talking about that. For now, let's just get started. Andy and Betsy both live in Mathville. I'll just say briefly, I did think the A test was quite challenging, meaning I think the cutoff's going to be like the 2024 10A from last year, probably around that level. I don't think it gets any higher than 96. There was just a lot of weird thought processes and time-consuming problems. I don't know. That's kind of my gut feeling, though, and that's what I'm going to go with. As far as the 12 goes, you can bet sub 90, maybe low 80s, maybe 87, I don't know, sub 90 somewhere. Andy and Betsy both live in Mathville. Andy leaves Mathville on his bicycle. Same problem for both of them, by the way. Leaves Mathville on his bicycle at 1:30, traveling due north at a steady 8 miles per hour. So here's Mathville. He's going to go north. Andy is traveling at 8 miles per hour. Betsy leaves on her bicycle, same point, 2:30, so hour later. So this is an hour later. She's going to be going due east. So this is at 1:30 and 2:30, and traveling due east at a steady 12 miles per hour. So she's going 12 miles per hour. At what time will they be exactly the same distance from their common starting point? So, I just look at it and go, what's the least common multiple? And I hope that's it. And then it is, actually. You get 24 here after 2 hours, and this one would be 24 after 3 hours, which is good because in 3 hours from his time, it'll be 4:30, and in 2 hours from there, it'll be 4:30. So those kinds of things, you don't have to always do an equation. You can just use logical guessing, and you anticipate they're going to be a multiple of each other, or a least common multiple of the two numbers is probably going to play a role. And if it didn't work, you could reason from that point as well to keep going. So it's going to be 4:30. Let's get on to the next problem. Continuing on with this rapid fire set for both the 10A and 12A, this was problem 2. A box contains 10 pounds of a nut mix that is 50% peanuts, 20% cashews, 30% almonds. So let's just go with that. 50% of 10 is 5 for peanuts. 20% cashews is going to be 2 for cashews. And the almonds are going to be 30%. Because it's 10, you're just breaking the 10 pounds into 50, 20, 30. Easy conversion. A second nut mix containing 20% peanuts, 40% cashews, and 40% almonds is added to the box, resulting in a new nut mix that is 40% peanuts. So if I took the peanuts that are here and I add them and I get 40%, 20% peanuts in the new one is 0.2x, where x is going to be the total over here that we don't know what it is, like we know the 10. So this is your total amount of the peanuts on top, and it's going to be out of 10 plus x. That is your total amount of pounds of nut mix in both the first set and the second set. You're going to set this equal to 40% because we had 20% of this x, which is 0.2x. That goes with this plus that over the total now needs to equal 40%, which is 2/5. So all we're going to do from here is cross multiply quickly, and it's really nice. You get 25 plus x, and on the other side you get 20 plus 2x. Move x over here and 20 over there to get x is equal to 5. Once you have that x is 5, what are we doing? How many pounds of cashews are now in the box? Well, 40% of the x, or 0.4x, is cashews. So if we have 5 pounds, 20% of 5 is 1. So 40% of 5 must be 2. And so you're going to have 2 pounds of cashews here, and you already had 2 pounds of cashews there. So the total will end up being 4. These are cashews. So it's 2 plus 0.4 times 5. You can also just multiply that, and you'll get 2 as well, and add it to this 2 to get your total answer, which is B, 4. Let's get to question 3. Continuing on from the 2025 10A, problem 3. How many isosceles triangles, and this is important, it is kind of a vocab gate here. You need to know that isosceles does not mean only 2 sides equal. It means at least 2 sides are equal. Don't forget that all equilateral triangles are in fact isosceles, and you did need to include that in this problem. So how many isosceles triangles are there with positive area, basically normal, whose side lengths are all positive integers and whose longest side has length 20, 25? So you have kind of 2 cases here. Your first case is going to be that 2025 is by itself, and I've got 2 lengths that are going to go like this. If they're both 1012, then they won't be big enough for the triangle inequality to make them have positive area. So the sum of any 2 sides must be greater than the third. That means that you could start at 1013, and you could go all the way from 1013 to 2024. I think here more about what you cut off. You cut off this out of 2024, it means that this amount here is 1012 ways. So that's 1012. And if you've looked for it now, you don't see it, which is good. They didn't try and trick you there. You do kind of realize that you're going to have to keep going a different way. So now you say, well, why couldn't I make them all 2025, like equilateral, like we said? And you could do that. And I, for a moment on my paper, wrote +1 here because I hadn't done my other case yet. Now, the other case will be when I have something here and 2025 is here and here. And of course, what can this number be? It can be 1. It's totally fine. This plus this is bigger than that. So then you can say this number here can be everything from 1 to 2025. But of course, that's the same +1 we wrote over here. So I'm just going to cross that out because it's much easier to count this if I just count this as 2025 and that as 1012 ways. And that's going to get you to 3037. This was probably the last quickish problem on the test as far as the A went. From here, they started to take quite a bit more time. I mean, there was a couple that were still pretty slick and quick as you went through, but the next question takes a little bit longer than this one does to really let it evolve and figure out what the answer is. Let's get to that one now. All right, so continuing on with the rapid fire for both 10A and 12A. It was the 10A problem 4. It was the 12A problem 3. A team of students is going to compete against a team of teachers. This is the first question on both tests. I thought it took a significant amount of time. If you spent 3 minutes on this, I don't think that's a problem. If you spent 5 minutes, it might not be bad. There's a lot of things to classify as a variable or an unknown, and there's a lot of equations to make, and it takes a little while to kind of figure out what the best approach is. I wouldn't even be surprised if some of you skipped. I don't think it's a terrible skip to go leave and come back to later on just because of how long the wording is. Okay, but going to compete against a team of teachers in a trivia contest, the total number of students and teachers is 15. I'm going to write x plus t I don't like S for students, and T sounds good for teachers, is 15. Ash, a cousin of one of the students, wants to join the contest. If Ash plays with the students, the average age on that team will increase from 12 to 14. So we are going to use a small notebook concept here, even though I didn't mention this one in the most recent class in all the classes, but the formula that I like for averages is the sum subscript n over n equals the average subscript n. So the sum of n things divided by the number of things is the average of those n things. That's how you want to think of it. So if we do that for the students here, this is the preferred averages formula. You get a lot of use out of this. I probably use it at least 6 times on the contest. So you're going to go sum of the students over x is currently 12, but if Ash joins them, then it's going to be the sum of x students plus Ash, which will be A, divided by x plus 1, the same x that we had before, and this is going to make it 14. Of course, after you write these, you should probably immediately multiply across. So then over here, I have the sum subscript x plus A is 14x plus 14. Now we go to the teachers. If he plays with the teachers, the age decreases from 55 to 52. I'm going to go ahead and take this t and subtract x. And so now we're going to say that the sum of the t over t is 55. So we can just go straight to 55t. You kind of get warmed up on this and you don't write the original equation anymore. You just go straight to the other one. We also know that the sum of the teachers plus Ash is going to equal 15 minus x is the number of teachers. Interesting. So we could probably replace this t if we want to later with 55 times 15 minus x as well. So over here we would be dividing by what? By t plus 1, and it would equal 52. But instead of putting t plus 1, we're going to put 15 minus x plus 1. Okay, so now what are we going to do? How old is Ash? All of these unknowns, the t, the x, and the A is the one that we're looking for. So what I would probably do is simply drop this 12x into the sum of x here, and I'm going to go ahead and subtract it over to here to get that A is equal to 2x plus 14. Over here at the same time, I'm probably going to do the same thing. I'm going to take this and put it over here. So I've got 55 times, I'm going to distribute as I move, minus 55x plus A, and A is going to equal 2x plus 14. This is going to equal 52 times 15 minus 52x plus 52. So now what I'm going to do is I'm going to take this. This is another trick on the contest too. Don't calculate unless you have to. Do not make a giant big number here. Look at how much better it is to keep. I've got 52 of these 15s. I've got 55 of these 15s. If I subtract this over to here, I will have 3 of those 15s. So I have 3 times 15. If I add 55x to the other side, this 52x will give me 3x. So I've got 3 times 15 plus 2x plus 14 equals 3x plus 52. So from that point, I am probably going to move the 2x over to here to get x equals. I've got 45 and 14 is 59. I'm going to have x equals 7. 45, just to double check, 45 and 14, 59 minus 52 is 7. Cool, we're going to take that 7 and put it right here in for A. 2 times 7 plus 14 is going to be 28, and that will be kind of clever. They put it as A, Ash, which was A. It's yeah, kind of nice there, right? So there's a lot of little things you have to do in here. It might take you a while to set this up. Just because I wrote it this quick on the boards, I'm just making a video. When I solved this test myself to see what it felt like as the student, I think I took probably about 3 minutes on this problem just to kind of get my bearings for what I wanted to create for the variables and the substitution and kind of figure out how that was all going to roll out. Let's go ahead and get to the next problem. Okay, so now we have the last problem of the first rapid fire for 2025 AMC 10A. Consider the sequence of positive integers, and they gave you a lot of them to look at, to think about what's going on here before asking you what is the 2025th term in this sequence. So your initial foray needs to be analysis. They don't even give you any hints about what's going on. You just have to figure it out. It's kind of climbing from 1 to 2 and then dropping to 1. And then it's climbing to 3, 1, 2, 3, almost like a mountain. 1, 2, 3, 2, 1. Like that. But this 1 is part of the next mountain, which is going to go up to 4 and then back down to 1 again. So the 1s are part of both the previous mountain and the next mountain. And so we're going to have to try and figure out how we're going to account for that and what do we even do with it. I'll leave that there for a little while in case we need it. So you're up to 4 down to 1, and then you're up to 5 down to 1, and up to 6 down to 1. How are we going to possibly figure out? It's not like we're adding the terms. We have to come up with a plan. And it takes a little bit to figure out what to do. You might wonder if there's some kind of a recursion, or if there's some other kind of thing, like I might have 1, 2, 1, 2, or how often the 2s occur. I have a 2, a 2, a 2, and a 2. They're not every other anymore, but maybe they are. 4, and then 2, and then 2, and then 4, and then 4, and then 2, and then 2, and then 4, and then... Basically, it's evens. Maybe we could do something with that. But I think what you have to ask is, what kind of, these are like the mountain things, right? Like, how many terms are in the first mountain here? 3. And that's kind of the first thing that's happening in the sequence. So if you write 3 plus, and then you look at the next one, how many are here? 1, 2, 3, 2, 1. But one of them specifically, literally the 1, is in both of them. So we counted it twice. Maybe we could add 5 for that iteration, and then we take away 1 down below. If I test that, there's 2 here and 5 here. There really is 7 terms up until that point. So that works. Okay, and then as the next one, we're going to be going up to 4. You have 4 plus 3. It really is 7. Hey, it kind of looks like the total number of terms, at least this part of it, is taking the form of the odd numbers. Let's just kind of check that out for the rest of the way and see if our hypothesis of how we might represent what's happening is valid. So we go to the next one, and we have up to 5, and then you add 4 is 9. And then you have up to 6, and then you add 5 is 11. And now we kind of start to get the feel for what is going on here. And every time you add an odd number, you will also subtract 1. And you say, okay, so how is this going to help? Do I want to do like nth term formula? You could do that. You could say a sub 1 is 3. I know what I'm going to do. I probably want to add these numbers up, and I happen to know the sum, small note, the concept, by the way, the sum of the first n odd integers, this is the nth odd, is equal to n squared. So if you add the first 3 odds, 1, 3, and 5, you get 9, which is 3 squared. But we don't have 1 easily fixed. We just add it to the front and also subtract it down below, and you're not really, these are being combined, by the way. All of this is going to be combined with this to know where we're actually at a given point in time after which mountain we finished at the bottom of. So we do want to confirm, and there are these little confirmations. We want to confirm that when I add 1, 3, and 5, and I get 9 and take away 2, I am still at 7, and that's at the end of my second mountain here. Okay, so I want to know how many how do I get this? I want to figure out what mountain we're about to start or what mountain we just finished, and then I'll reason from that point. And this is your first chance to use the fact that this is 45 squared. And since it's 45 squared, if I went to the 45th odd number, which would be what? By the way, the nth odd is always one less than the nth even. So the easiest thing to think about is not 2n minus 1, it's the 45th even, which is 90, and then take away 1. So don't really think about the n part, just find the even and go backwards 1. Okay? So it's going to be 89. So when you got to that point though, how many minus 1s would there be? Because we also have to go minus dot 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 minus 1. If you're on the second odd, you had 1 negative 1. Third odd, 2 negative 1s. 45th odd must be 44 negative 1s. So if I added this part up here, it's 2025, but I have to subtract 44 negative 1s, which means you're 44 below that point. So we're not there. We have to add 44 terms now. Where are we at? We're at the bottom of a mountain, specifically the mountain that would go up to, what is the middle number of 89? It's 45. You're basically going, this term right here is 1, 2, 3, dot, 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 45, 44, dot, 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 3, 2, 1. So you're counting up to 45 and back down to 1. And then this 1 is going to be where you start going back up again on your next term, which will be a 91 term mountain, if you will. I'm making up the word mountain. You get to make up your own words on the test. It's really kind of nice. Make up whatever you want that makes sense to you. You could call it a hill. You could call it a 4-3, like there's a 3-2 here and there's a 4-3 here. Call it what you want, right? It's whatever you'd like to think of it as. Whatever makes sense in your brain, it's perfect, okay? So now we are at the bottom of this mountain on the number 1 and we need to add 44. So I just go to the next term. If I wanted to get to 2, how much should I add from 1 to get to 2? I added 1. Good. We feel very comfortable adding 44 to 1 and knowing confidently it's this and not this lurking answer trying to get you here. Probably what this is for is people who kind of forgot that the 1 is part of the previous mountain and the next mountain. Again, mountain is a term I've made up. It's people who forgot that and they thought they have to add 44 and 1 to 44 is 44. So they're quick, they're under pressure. You've already taken some time figuring out what this sequence was. If you took 4 or 5 minutes on this test question, I don't have a problem with that. It's hard to figure out how you're going to make some kind of a rule for this. And it took me a little while to come up with this plan. It wasn't like I knew instantly to group them by what they're doing. But after you think about it, it kind of makes sense to group them by the package of what they're doing. It's these that make up the next iteration of what's taking place in the problem. It's going up to 4 and then down to 1, and then up to 5 and then down to 1. But every time we overlap by 1 term, so we subtract 1, and that's exactly what I wrote on my paper. If you look here, I'll show you what you can see here. It's the same exact sequence that I made, and it took me a little bit to get there, okay? So that's it for this problem, and we're going to get on to the next set of 5 right after this.